Hey there, fellow video freaks and AV geeks. Dr. Yo coming at you once again with another episode of Video Synth Tools and Techniques, in which I attempt to share what I've learned about video synthesis and the LZX modular ecosystem. Today I want to talk about sample and hold. The purpose in this context is to hold some control voltage for the duration of an entire frame. If you don't do this, then you may run into issues such as frame tearing or distortion. These are artifacts of video synthesis that come about because it can actually operate sort of within a frame. Inside the duration of a frame, something can happen, and that can be desirable or not. This is kind of similar to the rolling shutter effect that you might see, in which the sensor is always active. So it's unlike most video cameras, a CCD camera, for example, in which the shutter opens, it collects all the light, and then the shutter closes. Well, with a rolling shutter, it's always open, and if something moves while the frame is being captured, then you'll get distortion. Same thing happens with a video synthesizer, and the way you can avoid that is to use sample and hold. Sample and hold is one of the most common of all audio circuits, and it's actually the foundation of all digital audio. It takes an incoming signal, such as an audio wave, and samples it at a particular time and holds that value until the next sample. We're going to use it in this context to sample a control voltage so it won't change over the course of a frame. In a musical context, sample and hold is generally used to convert some continuously varying value, such as the pitch of a musical note, and convert that into a quantized stair-stepping effect. As I reduce the frequency of the trigger signal that's causing the sample to be taken place, we get slower and slower tempos to this stair-stepping effect. Because sample and hold is such a common audio circuit, there are many modules from which to choose. For example, you could use the tip-top audio source of uncertainty, the Buchla clone. It has a sample hold circuit built into it. Or you could use Ornament and Crime or the Expert Sleepers Disting. These are multifunction modules, and sample and hold is just one of the many things they can do. I'm going to use the Pulp Logic sample hold tile. I have a number of these because I may want to sample multiple control voltages. For our purposes in video synth land, we want to take a sample at the beginning of each frame or field and hold that value for the entire frame or field. That means that our sample frequency needs to be our frame rate or field rate. The easiest way to accomplish that is to use the V-Sync output, if you have it, on an LZX modular system. Now, as of November 2023, there is no LZX module in production that has a V-Sync output. But if you're working in standard definition and you have a visual cortex or you have a cadet sync generator, then you can take that V-Sync output and plug it directly into your sample hold trigger input. And it should work just fine because that V-Sync output is a positive voltage. It goes high whenever a new frame or field starts. However, that V-Sync output is a 1 volt signal, and you may find that you're not able to get an audio sample and hold module to actually trigger from a 1 volt signal. So you can either bump that up to 5 volts using a voltage converter, or you can use a comparator, which is set to a threshold below 1 volt, and it will output a 5 volt signal. If you're working in a high definition format and/or you don't have visual cortex or the cadet sync generator, then you'll have to find another way because V-Sync is not an option for you. I'll show you a couple ways you can accomplish it. First, using an inverted vertical ramp, and second, using a sawtooth wave that is locked to the vertical frame rate. Let's take a look. Here's how we can avoid the horizontal tearing that is all too common in a video synth patch that uses a sudden transition, such as this one, in which I'm using a square wave to switch between two different images. If I increase the frequency of that oscillator, we'll go into flicker zone, so warning, flicker zone. At higher and higher frequency, the horizontal tearing becomes quite apparent, and that's really not the artistic look I'm going for. We can avoid this using sample and hold, so that we hold the control voltage for the entire duration of each frame, and we won't get a transition in the middle of a frame. All right, so let's take a look at the patch here. The specific patch is not that important. This would apply to any situation in which we have a control voltage that's changing really suddenly. In this case, I'm using the DW03 square wave output. It's going into 3 bridges, acting as a crossfader. But again, this will apply in any situation in which you have a sudden transition in a control voltage. Now, the first way I'm going to correct for this is using a ramp. So let's take a look at that. I've got my DSG3 here, and I've inserted a dummy plug into the horizontal channel here of shape number 2. And I'm going to just show you what that looks like, okay? So I'm going to go patch the absolute value output to my encoder. It's just a ramp. There's really nothing going on there. The important thing in this case, though, is that it's an inverted ramp. So here's the default ramp, which goes from black at the top to white at the bottom. We want the opposite. In this case, I want to employ the feature to invert that ramp. All right. So I'm going to put this back to my RGB signal. I'm going to take that ramp and use it as the input to a comparator, a compare tile from Pulp Logic, and also sample and holds. You can see that I've got several of these sample and hold tiles. I'll need one for each signal that I want to constrain to the vertical frame rate. Let's say I wanted to affect the red, green, and blue separately, and I wanted to make sure there was no tearing in any of those channels. I would need 3 sample and hold modules to do that. The other thing, of course, with these audio modules is they require a 5-volt signal at the sample and hold trigger input here. And so that's what the comparator is for. I could probably use a 5 times scaler to accomplish that, but the comparator is probably a better way to go. It's more reliable. It's going to see an incoming waveform, in this case that vertical ramp, and when that ramp crosses some threshold set through the knob here, then it will cause a 5-volt signal to come out. All right, so that's our patch here. We're going to take the comparator output, and it's going to go into the trigger input of the sample and hold. And then we need to supply something to the comparator input, and that is the vertical ramp coming from DSG3 in this case. And then we need to pass our control voltage, our modulation signal, through the sample and hold. Here is the modulation signal. I'll take that and pipe it through the sample and hold. Sample and hold in. And then we got sample and hold out. And that's going to go where that modulation signal was originally. Boom. No more tearing. Looks good to me. It's beautiful. And I can play with the frequency of my DW03 and go up into, crazy psychedelic flicker zones. But we'll never get any tearing. Now again, if we switch out this setting here, if we set this to not inverted, then we don't get the result we want. We're back to tearing. All right, cool. Now, the one thing though is this is kind of a waste of DSG3, or likewise, it would be a waste of one of the RGB channels of TBC2. I really don't want to use those if I don't have to. There's another way I can go about this, and that is using the sawtooth oscillator I've got here. Really, any oscillator that will lock to the video signal will work. You may need to adjust the bias of that signal in order to get it to, work with the comparator. But I love the Symphony VU09 sawtooth because it has a built-in offset control here, and that's a bias. So I don't need to run a ramp through a proc or other bias control in order to make sure I get it into the right levels for the comparator. So I'm going to switch this over. Instead of using the DSG3, I'm going to take the output of my VU009 sawtooth. And it's actually already set up. I've already set the frequency, but I should probably show you what that looks like because it's not immediately obvious. So I'll take that sawtooth output and go directly into the encoder. So this is what we got. We've got a signal that's going, once again, from white at the top to black at the bottom. And I've got the offset control here. I can play with that just to show you what we're getting. So here's the frequency. And again, we want to make sure that we're in the right range. So we don't want, a pattern of bars. We want a single ramp if we can get it. So as I bring this down, we get closer and closer to that. And we may need to, again, tweak it because it is analog and it's never going to be exactly what we want. We'll get something close. And then again, I've got my offset. So it just needs to be locked to the vertical frequency, really. And that's probably good enough. You'll see we're not getting the full range of black to white here, but that doesn't matter because we're going through a comparator anyway. So put the patch back the way I had it, and boom, we got what we wanted. Beautiful. And I'm not using my DSG3 or TBC2, which are expensive modules, both literally and figuratively. And the VU009 does the job just fine. And you can see I've mounted it here really close. All right, that's how to correct for horizontal tearing using a ramp or a sawtooth. Here's another use case for the sample and hold patch. I've got these vertical bars. They're coming from a DW03, and it's being frequency modulated by another channel of DW03. And that's causing the size of those bars to change. But you'll see that the shape is also changing. They're distorting. They're kind of weaseling around. And that, again, is happening because the transition, in this case, the frequency modulation oscillator, is close to the frequency of the vertical frame rate. All right, so how do we correct for this? Once again, sample and hold. So let's take a look. Go now to our patch once again. So here's the modulation. I've got this channel of DW03 going into the frequency modulation of the other channel. And that is then once again providing the transition. So we can take a look at that in video land as well. So the key here is that we need to choose correctly which of these oscillators we want to lock to the vertical interval. So if I took this output as we did before, it wouldn't work because this is a frequency higher than the frame rate. That's the only way we're going to get these vertical bars in the first place. It's got to be way up there in, the megahertz range. So if we took this output and put it through our sample and hold chain, we would not get bars anymore because the whole purpose of sample and hold is to hold a single voltage for the entire duration of the frame. And of course, that wouldn't work in this case. We would basically get a flat image and no keying would take place. There'd be no transition. Okay, so what we want to do actually is sample and hold this guy that is affecting the frequency of the final video rate oscillator. Okay, so let's get that sorted out. So instead of going directly into this channel, I'm going to take that out. And I've got the output of that. That's, in this case, it's a triangle wave. It's going to go into my sample and hold input. And the sample and hold output is going to go into that frequency modulation input. Boom. we're getting that frequency modulation, and it's changing the size of those bars, but we're not getting that weaseling around where it's actually changing shape. And I can adjust the frequency of those bars and get different looks. Cool. And this would apply in any situation when you've got lines that are moving pretty fast. If they're moving fast enough, they'll interfere with the frame rate, and that'll cause the shape to distort, and you can correct that by going through sample and hold. All right, pretty cool stuff.